Bev again with another request video. And this video is on energy production systems. Now, I want to say at the outset, this is not a simple subject. But if you've seen my videos, you know I like to take a complex area of discussion and just reduce it down to the basics, right? That's all we want, the basics. But your body always needs energy, 24 hours a day. It needs oxygen to produce energy. It doesn't care where it gets the oxygen. It will get it where it has to get it from. So your body will use multiple energy systems to do that. Although it depends really on what you're doing, because sometimes there's a more predominant one, right? So you will have heard of these two energy systems. They're actually metabolisms. Anaerobic, which is non-oxidative, and aerobic, which is oxidative. What do we mean? Well, if it's oxidative, you're going to be using respiratory oxygen for fuel. If it's non-oxidative, I said you need oxygen, you're going to be getting it from your body, okay? Now, if you're weightlifting, the dominant systems will be on this side. And if you're into endurance sports like marathon running, the dominant system is going to be on this side. And really, you're only maybe 100% aerobic. Maybe if you're in a deep REM sleep and you're not moving at all, just your eyes are moving, watching, nightmares or dreams or whatever. But that's the only time you're 100% aerobic. You're always a mixture of all of this stuff. But let me give you some caution here. On this side, if you are not highly physically fit, you don't last long in the aerobic area. And that's because you cannot get enough oxygen far enough in your body to the working muscles. And also, you just can't break down fatty acids anymore because you can't move that oxygen. Fatty acids, you always want to break down fat when you're running, right? Fatty acids are comprised of hydrogen and carbon. Now, when you add respiratory oxygen to hydrogen, you get water, great. And when you add it to carbon, you get carbon dioxide, super, you just breathe it out. But if you can't keep that oxygen coming in, you've got a problem. But you don't listen to the messages, right? You're running on the treadmill, you're sweating, you're coughing, you're red in the face, you can't talk to the person next to you in good sentences, and you think, oh, I'm really aerobic, I'm really burning a lot of fat. Maybe you're not, because your body needs oxygen. You can't provide it. Where does it go? It's going to go into your body and it's going to get oxygen because you are not listening to your body and it has to save you, right? So what it does is it will, there's something called glycogen in the body, and it has hydrogen, yes, carbon, yes, and oxygen, and that's what your body wants. So be careful on this side. What do I want to say? Oh, let's start down this pathway. This is for short bursts of energy, right? It's an immediate source of energy. It doesn't last very long, and it uses things called ATP and CP. I'll explain that in a minute. But if you're running for a bus, like something really quick, but because ATP and CP are in the muscles and they're rapidly depleted, the ATP has to be replenished, and that becomes the job of other energy systems, okay? That's what I wanted to say. But let's talk about what is ATP. It's an energy-carrying molecule, very critical in the body for energy. And you can Google it, right? Just ATP, it'll pop up. It is adenosine triphosphate. Now, as you use it up, it becomes adenosine diphosphate. And to make that back into ATP, which your body needs to do, it takes creatine phosphate and it adds a phosphate back. Kind of chemistry details you don't probably need to know. But ATP captures, your body captures chemical energy from food when it's broken down. and it releases it as fuel into your cells. And that's what's involved in this ATP business. And really, I kind of think of ATP as kind of my body's ATM machine. You know how your ATM machine at the bank, you put money in, you get money out, you put money in, you put money. The same thing with ATP. You know, your body is always using it, making it, using it, making it with this creatine phosphate, using it, making it, just goes on. Now, the second pathway is different. It's a bit slow, but it does last 1 to 3 minutes, right? Longer than this one. But it uses glycogen, which are stored carbs in your body. So those stored carbs are broken down into glucose energy in the muscles. And then that gets converted back into ATP. Remember I said you need that. So glycogen is stored in your liver, but mostly in your muscles. Now, the other thing that, not only glucose, but lactate can be produced in this pathway as well. And people, you know, they fear lactate, but they really should not fear lactate. Lactate is really an intermediate link between these two metabolisms. It improves endurance, and what it is it's really an energy fuel for your mitochondria. It's not a waste product like people think. So, you know, if you're doing an exercise, let's say you're doing curls, oh my God, and you can't do one more curl in proper form, and you have this burning feeling, that's lactate. But it's not to be feared. It's a message from your body, and what you have to do is just stop doing your curls. The lactate will dissipate. Lactate is actually, as I say, fuel. You know, people say, oh, you have to get rid of it. No, it'll just dissipate on its own. Just go on to the next exercise. You'll be fine. Anyway, I hope this helps you understand how amazing your body is at giving you energy. So I'll see you in the next video. Bye for now.